Scientists are keeping an eye out for light on the exoplanet Proxima B in outer space in hopes that it may provide the last conclusive proof that extraterrestrial life exists. But the James Webb Space Telescope's most alarming find on Proxima B isn't even that. How terribly do you think this Proxima B finding could be, and how does it affect the likelihood that humans will send explorers to this distant planet? Stay with me until the very end as we explore the James Webb Space Telescopes and witness the shocking discovery on Proxima B that drastically alters everything. Elon Musk's SpaceX is leading the charge to establish a permanent human outspot on Mars, which could be the next planet to support life. Mars is relatively close to Earth, making it possible to send people there, despite the difficulty of such a journey. However, much farther out in the universe are a class of planets that we shall soon focus on one of them. They are known as an exoplanet. What are exoplanets? Exoplanets are simply planets orbiting a star other than our Sun. The prefix exo points to the fact that these planets are located not just outside, but far outside of the solar system. Astronomers have confirmed thousands of exoplanets revolving around these distant stars, and there are more yet to be confirmed. The first two exoplanets were discovered orbiting a pulsar in 1992, and the first one confirmed to be orbiting a star like a Sun was in 1995. Astronomers have confirmed thousands of exoplanets revolving around these faraway stars, and there are still more to be confirmed. Exoplanet discoveries have the potential to be more effective than current scientific technology. Exoplanets like Proxima B are challenging to find for some reasons. They are light years away from us and are very, very far away. Another problem is that, unlike Earth, exoplanets merely reflect light from the star that they orbit rather than producing any light of their own. In contrast, even the largest of the exoplanets are drowned in the brightness of their incredibly brightest stars. Because of this, even the brightest ones are too small to be seen with optical telescopes. One thing about our own solar system has been revealed by the discovery of exoplanets. This is strange in the world of star planning systems because, before the discovery of exoplanets, the majority of scientists believed that, if any, such planets would resemble our solar system's planets. However, they were surprised to find a wide variety of positions and orbits that are difficult to understand. Exoplanets come in a variety of shapes and sizes, including hot Jupiters, so named because of their mass similarity to Jupiter and predominant gas composition. Then there are the super-Earth planets, which have masses somewhere between Earth and the two tiniest gas giants in our solar system, Neptune and Uranus. We're more likely to resemble terrestrial planets like Mercury, Venus, Earth and Mars because such planets are more likely to be composed of rock than of mostly gas. Some exoplanets have masses up to 10 times that of Earth. They are smaller than Neptune though. Ocean exoplanets are those that have lots of water, whereas ice giants exoplanets are those that are composed of volatile substances like water, methane, and ammonia rather than the hydrogen and helium of Jupiter and Saturn. Of all the commonly known exoplanets, none attracts as much curiosity as Proxima B, and a high degree of interest will only increase with the upcoming James Webb Space Telescope. One of the reasons scientists study exoplanets is to discover if some of them can support life. The existence of Proxima B, which is about in the center of the Proxima Centauri star's habitable zone, was verified in 2016. The European Southern Observatory's High Precision Radial Velocity Planet Search, or HARPS, at La Silla, Chile, made it feasible to find it. The Sun's closest stellar companion, Proxima Centauri, is only 4.25 light-years distant. Using the naming technique utilized by planet-finding astronomers, scientists chose the moniker Proxima B for the star. Beginning with B for the first planet discovered, C for the second, and so forth, it begins with the name of the star, followed by the lowercase letters. Although the letter A is only used for the star itself, you may inquire about the planet Proxima A. The letters in the names are arranged according to the sequence in which they were discovered, not according to how far away they are from the parent star. So how does Proxima B appear? Proxima orbit B is inclined with the Earth so that it avoids passing directly across the star's disk. As a result, astronomers were unable to discover it using NASA's Kepler mission's method of exploiting blocked starlight. Instead, the planet's existence was inferred from the star's radial line of sight velocity wobble caused by the planet's 11.2-day orbit. When the planet was discovered, scientists also found flimsy evidence that suggested a second planet, which later proved to be true. With only 12.3% of the Sun's mass, 14.1% of its radius, and 0.17% of its net energy production, Proxima Centauri is a dim red dwarf star. Its habitable zone must therefore be somewhat near to the star. Proxima Centauri, like the majority of tiny stars, is comparatively unstable. and is noted for frequently generating massive solar flares. Its corona is quite cool, at 3042 Kelvin compared to our Sun's 5772 Kelvin. It emits more infrared light than visible light mostly. Because of this, despite being so close, you cannot see it in the sky with the naked eye because it's so dark. Due to its relative coolness and the reduced star material imports caused by gravity, Proxima Centauri has an extremely high density. Proxima Centauri has a density that is roughly 56.8 times that of water and 7.23 times of iron, yet the Sound has a density that is 1.41 times that of water. However, because of the extremely low energy production of Alpha Centauri, Proxima Typical B's surface temperature falls within the region where water should be liquid. Proxima B is tidally locked to Alpha Centauri. What does this mean and what are the consequences? You're surely aware of the tidal influences that the Sun and Moon have on the oceans of the Earth. The strength of this kind of force is determined by the mass density of the producing objects and by the angular size of the third object in the sky. Also, Proxima is 40 times as dense as the Sun. In other words, Proxima Centauri's tidal force on Proxima B will be 939 times stronger than the Sun's on Earth. As a result, Proxima B is probably still in tidal lock with Proxima Centauri. In this region, the temperature will be extremely hot or cold. A tidally locked planet does, however, have some benefits. For instance, if people lived there, solar energy farms would always provide electricity. The remainder of the exoplanet will then receive electricity as needed. So if you take plants from the Earth to Proxima B, they can only photosynthesize with a small portion of the sunlight from Proxima Centauri, but there is a way to guarantee that you will always have access to fresh food. At approximately 700 nanometers, silicon solar cells had their highest conversion efficiency, which fell to zero at 1100 nanometers. Therefore, it may be possible to cultivate crops on Proxima B by locating massive solar energy farms and absorb 700 nanometer light on the planet's hot side and growing plants in twilight zone greenhouses lit by electrically driven LEDs that emit 470 and 660 nanometer wavelengths. But what about gravity on Proxima B? Well, this exoplanet also has gravity, and it's at least 1.3 times as powerful as the Earth. If Proxima B is spherical, with a tremendous mass of 1.5 masses and roughly the same mass density as Earth, it might be even more powerful. The surface gravity on Proxima B would be around 1.145 g or 11.22 meters per second square. You thereby tip the scales 14% more than on Earth, and there is another factor that could dramatically alter our assessment. As you can see, the Earth's iron-nickel core gives it a rather high density. However, Mars and Proxima B might not have the same core. Proxima B has the same mass density as Mars, or 3.93 grams per cubic centimeter, as a result. When this happens, Proxima B's surface gravity will be 0.866 grams or 8.5 meters per second square, and it will weigh 14% less than it does on Earth. However, the enormous tidal forces may prevent Proxima B from being spherical. Instead, they may cause the planet to have an ovoid egg-shaped structure with a long axis pointing towards the star. Therefore, the habitable mid-region would be closer to the planet's center, since it would be in the middle of the ovoid where its radius would be the shortest. If the radius were 10% smaller there, the gravity would be 20% more, yet it would be higher here than in the hot and cold zones. Please take a moment to like and subscribe to this channel. You can also let us know what you think about Proxima B in the comment section below.